Science fiction is jam-packed with impossible ideas, from invisible monsters to ripples in space-time. But what happens when the craziest stories we tell about the universe turn out to be true? For centuries, we've waved off certain cosmic tales as pure fantasy, only for science to prove them terrifyingly real. Since the dawn of civilization, we've looked up at the stars and told stories. Most were just that, stories. But every so often, a wild guess, a myth, or even a weird outcome in a physics equation turns out to be a shocking reality. Today, we're counting down 10 space myths that actually became fact, revealing the unbelievable tales that jumped from fiction to reality. Let's kick things off with the ultimate cosmic monster, the black hole. For decades, they weren't a discovery, but a ghost hiding in Albert Einstein's equations. Even Einstein himself thought the idea was too bizarre to be real. A star collapsing so completely that its gravity becomes like a waterfall with no bottom. It seems like a mathematical fantasy. Then, astronomers started noticing things. Stars were seen orbiting what looked like empty space, like they were waltzing with an invisible dance partner. The myth finally shattered in 2019 when the Event Horizon telescope captured the first ever direct image of a supermassive black hole. These invisible giants are not only real, they're a key player in how our entire universe evolves. The idea that the universe is getting bigger was once met with a lot of resistance. For most of human history, it was just assumed the universe was a static, unchanging stage. The concept of an expanding cosmos was so strange, even Einstein pushed back. Think of it like a loaf of raisin bread baking in an oven. As the dough expands, every raisin moves away from every other raisin. That's our universe. Edwin Hubble's observations of distant galaxies all rushing away from us, plus the discovery of the cosmic microwave background, like the faint, lingering warmth from the cosmic oven, providing overwhelming proof. What was once a controversial theory is now a core principle of modern cosmology. Pop quiz. What colour is the sun? If you said yellow, you're in good company, but you're also wrong. Our star only looks yellow because Earth's atmosphere acts like a filter. It scatters the cooler blue light more easily, letting the warmer yellowish tones shine through to our eyes. But if you were floating in space, you'd see its true colour, a brilliant, intense white. That's because the sun emits light across all colours of the visible spectrum in roughly equal amounts. Our eyes blend all those colours together, and the result is pure white. You've probably heard of the dark side of the moon. But here's the thing, it doesn't exist. Not really. The myth comes from the fact that the moon is tidally locked with Earth. It's like a dancer who always keeps their face pointing towards their partner. We only ever see that one face. This led people to think the far side must be permanently dark. In reality, both sides of the moon get plenty of sunlight, each experiencing a day and night that lasts about 2 Earth weeks. Over a year, both the near and far side get bathed in roughly the same amount of sunlight. A century ago, Einstein predicted that huge cosmic events would create ripples in the very fabric of space-time. Imagine dropping a bowling ball into a trampoline. That's what a black hole does to space-time, sending waves outward. For 100 years, these gravitational waves were just a theory. Detecting them seemed as impossible as trying to hear a pin drop in the middle of a hurricane. But then, on September 14, 2015, the LIGO detectors did the impossible. They picked up the faint chirp of two black holes that had merged 1.3 billion years ago, finally proving Einstein's space-time ripples are real. You might imagine a comet's tail streaming right behind it, like smoke from a chimney. But a comet's tail is more like a windsock. It always points away from the sun, no matter which way the comet is moving. That's because a comet is a dirty snowball that spews out gas and dust when the sun's heat warms it up. The solar wind, a constant stream of particles flowing from the sun, pushes that gas straight back. A second tail, made of dust, is a bit heavier and can curve slightly, but the sun is always the one directing the cosmic show. But here's one that I've already done before, and if you want to see the full in-depth analysis of it, check it out up there. It's the old myth that you can see the Great Wall of China from the moon. That's definitely false. But the idea that it's visible from space is a surprising nugget of truth. While you can't see it with the naked eye from the International Space Station, astronauts have managed to photograph it from a low Earth orbit. Spotting it is incredibly hard, like trying to see a single grey thread on a patchwork quilt from a distance. But with a powerful zoom lens and perfect conditions, it can be done. For years, astronomers were stumped. Galaxies were spinning way too fast, like a merry-go-round that should have flung itself apart, and the universe's expansion was mysteriously speeding up. So scientists proposed a wild idea. Maybe the universe is held together by invisible dark matter, acting like an unseen scaffolding that provides extra gravity, and is being pushed apart by an equally invisible dark energy. For a long time, these were just placeholders. Now, they're a critical part of our cosmic model, believed to make up a mind-blowing 95% of the entire universe. Is space hot or cold? The simple answer is that the vacuum of space has no temperature. Just like an empty room doesn't really have a temperature until you put something in it. The baseline temperature of the universe itself is a frosty 2.7 Kelvin, or minus 455 degrees Fahrenheit. However, an object in space can experience wild temperature swings. If you're floating in direct sunlight from Earth, you could heat up to over 200 degrees Fahrenheit. But step into the shade of your spaceship, you instantly plummet to hundreds of degrees below zero. Today, the Big Bang is the leading explanation for our cosmic origins, but it was once a massively controversial idea. Many scientists preferred the steady state theory, the idea that the universe was an eternal, unchanging forest that had always been here. The concept of the entire cosmos bursting from a single hot, dense seed was even mocked by its opponents. But as evidence piled up, from the expansion of the universe to its faint microwave afterglow, the Big Bang won out. While there are still questions about the universe's first moments, the core idea that our cosmos had a beginning has shifted from a wild myth to the bedrock of modern science. From cosmic horrors to the real colour of our sun, the universe is always challenging what we think we know. If you want to keep exploring the cosmos and busting more myths, make sure to subscribe and ring that notification bell. The line between science fiction and science fact is constantly shifting. Ideas that feel impossible today could easily be tomorrow's biggest discoveries. What we once wrote off as myths, black holes, space-time ripples, and expanding universe, are now just part of our reality. It proves that the universe is a far stranger and more wonderful than we could have ever imagined. Thanks for watching.